Good day, Ma'am Sapranco. So we are the group 4 and we are going to tackle the unit 10, which is the spherical Earth, astronomical observation before the advent of telescope, Kepler's discoveries from Brahe's astronomical data. For introduction, represents Earth in Greek mythology, known as the mother of life and goddesses. Early civilizations were curious about the Earth and the universe beyond it. So the Greek philosophers such as Aristotle, Ptolemy, Galileo formed early ideas about the cosmos through observations and reasoning. So their theories lay the foundations of astronomy through May were later revised with the inventions and telescopes leading modern scientific understanding. So the flat Earth model. So the flat Earth model claims that Earth is a flat disk or plane. Ancient Egyptians and Mesopotamians believed that Earth was a disk surrounded by water. Homer, 8th centuries BC, shared a similar view, a circular flat Earth encircled by oceans. So Israelites believes the Earth floated on water beneath a solid domed sky holding the sun, moon, and stars. This belief was proven wrong, and the spherical Earth idea emerged in 6th century BC. In history of spherical Earth model, on the 6th century BC, Pythagoras proposed that Earth is round, challenges the flat Earth belief. Around 430 BCE, Anaxagoras supported the idea through lunar eclipse observations, noting the Earth's circular shadows on the moon. So, Aristotle evidence for a spherical Earth around 340 BCE observed that the moon and sun are spherical, suggesting Earth might be too. Noted that the North Stars appears lower in the sky when traveling south, proving Earth's curvature. Observes that the shape disappear whole first over the horizon, showing Earth's surface is curved. Eratosthenes' measurement of Earth's circumference 240 BCE noted that a serene no shadow was cast at noon during the summer solstice, but in Alexandria a shadow appeared. Measures the sun angle in Alexandria as 7.2 degree while in Seine it was 0 degree. Concluded that the sun rays are parallel and the Earth is curved. Calculated Earth circumference equals to 46,250 km. It equals to 250,000 stadia.
So good day, now let me discuss the modern evidences supporting the spherical Earth model. Nowadays, many photographs of the Earth is being captured by the satellite of different government agencies and private institutions. Based on these photos, the Earth is plainly spherical. Moreover, the astronauts orbiting in the low Earth orbit personally observe the planet's curvature. Even the astronauts that stepped into the moon believes or attests that the Earth is spherical. So most of us back when we were kids thinks that the Earth is a circle. But because of the help of these evidences like the spacecraft, it helps us to determine whether the Earth is a spherical or a circle. So what does a spacecraft mean? A spacecraft, it is a vehicle that flies into space. It can carry astronauts, cargo, or instruments to its destination, or it can be the destination. An example of this is the International Space Station. Just like the smaller vehicle, it can deliver crew and cargo to it. So now let's proceed to another modern evidence, which is the lunar eclipse. So what is lunar eclipse? Lunar eclipse, it is also called the blood moon. It is an astronomical event that occurs when the moon moves into the Earth's shadow, causing the moon to be darkened. So what happens on the lunar eclipse? When the Earth is positioned precisely between the moon and the sun, Earth's shadow falls under the surface of the moon, leaving it something during the lunar surface striking red over the course of the in a few hours. So now let's proceed to the lunar eclipse. A lunar eclipse is also called a blood moon. It is an astronomical event that occurs when the moon moves into the Earth's shadow, causing the moon to be darkened. So what happens on a lunar eclipse? When the Earth is positioned precisely between the moon and the sun, Earth's shadow falls upon the surface of the moon, dimming it, and something is turning the lunar surface into a striking red over a course of a few hours. Every lunar eclipse is visible in half of the Earth. So due to the lunar eclipse, the shadow of the Earth formed from one side of the moon shows a dark circle. It moves from one end to another. This is due to the flat disk that faces the moon during the eclipse, and the shape that casts the moon shows a spherical shape. So this picture shows the lunar eclipse. So next is the time zone. The time in New York is 12 p.m. when the sun is highly visible into the sky, and 12 a.m. in Beijing when the sun is not around. So the time difference between two distant places in the world is due to the time zone. The presence of the different time zone can only be explained if the world is round and continuously rotating to its axis. Due to this movement, the sun is present on the other side of the Earth and absent on the opposite or dark side of the Earth. So there is a 24 hours on the Earth. It is a period to complete one full rotation to its axis. Time zones are determined by the Earth rotation relative to the Sun, dividing the planet into different time zones based on the longitudinal degrees. And lastly is the writing a planet. Last evidence is the writing a planet. There are two things that you should observe when writing a planet. First, the airplane are capable of traveling in a straight line forward without falling off any edges, even for some time. And the airplane can circle on the Earth without stopping. Next is the curvature of the Earth on the horizon is noticeable, especially if you are traveling in a transatlantic flight. So did you know that according to Isaac Newton, the Earth is not perfectly round. The actual shape of the Earth is oblate spheroid or spherical. It is a sphere that has a little flat on its pole and has a sloping equator. Because of this shape, the actual distance from the sea level of the Earth center at the equator is approximately 21 kilometers greater than at the pole. So that's all for the modern evidences that support the spherical Earth model.
So good day everyone. So we are now talking about the earliest astronomical observation. So earliest astronomical observation is one of the earliest records of astronomic observation was documented in the nebula sky disk collected from the northern Europe and was dated at approximately 6000 BC. It is a 30-kilometer bronze disk showing planetary objects like sun, lunar crescent, and a lot of stars. Scientists have explained that the nebula sky disk can be religious symbol and astronomical calendar. This same concept has also developed in the Western Hemisphere that focus on understanding stellar and planetary behavior. So the Native Americans created the same picture of the sky on rocks. One of the clearest example of early rocks drawing is so next we are now talking about the Ptolemy. Ptolemy is an ancient Greek astronomer and a mathematician provided the mathematical foundation of the solar system model. This was based on Aristotle's idea of planetary motion. Ptolemy was one of the scientists to answer the play to save the appearance. He was able to write treatise on planet motion and the celestial sphere.
Good day, Ma'am Nelda F. Franco. I am Giancarlo M. Cadacio and I am here to tackle my topic, Renaissance in Astronomical Observation. Renaissance is a period when new ideas were developed in Central Europe. These ideas were considered more important than the dogma. During this time, the Roman Catholic Church adopted Aristotle and Ptolemy's doctrine on astronomy. So the Renaissance was the time when new ideas were developed in Central Europe. These ideas became more important than dogma. In the Roman Catholic Church, followed Aristotle and Ptolemy's belief about astronomy. So now let us know about Nicolaus Copernicus. Nicolaus Copernicus in 1500s reintroduced the heliocentric theory that challenged the doctrine of the Catholic Church. Also during this time, a better understanding of planetary of motion was introduced. In particular the idea of rotating Earth was pointed as the reason for the diurnal motion of stars. The heliocentric model of Copernicus improved the explanation regarding a retrograde motion by placing the Sun at the center of the solar system. So Nicolaus Copernicus reintroduced the heliocentric theory, which went against the Catholic Church. He explained that the rotation of the Earth causes the motions of stars and placed the Sun at the center of the solar system. Next is Tycho Brahe. Tycho Brahe in 1580s is considered the first astronomical observer. He founded the Danish Observatory, where he tried to measure the accurate position of the planets and stars. He insisted that the Sun is farther than the Moon from the Earth. Tycho Brahe is known as the first astronomical observer. He built the Danish Observatory and measured the exact position of planets and stars, proving that the Sun is farther from Earth than the Moon. Moreover, Johannes Kepler in 1600 is a student of Tycho, utilized the data from Brahe's observation and formulated the laws of planetary motion that corrected the conflicts to epiphysicals and heliocentrics theory through the introduction of elliptic orbits. So Johannes Kepler, a student of Tycho Brahe, used his teacher's data to create the laws of planetary motion. He corrected the heliocentric theory by introducing elliptical orbits. In the 1600s, Galileo Galilei pioneered astronomical observation and constructed the first small refracting telescope. This opened new doors of the improvements of the existing astronomical beliefs during the Renaissance era. So, in the 1620s, Galileo Galilei made the first small refracting telescope. His work opened new doors and improved astronomical beliefs during the Renaissance.
One of the records of astronomical observation was documented in the Nerva sky disk collected from Northern Europe and was dated in approximately 16 BC. Thales, 480 BC, a well-known Greek philosopher, used the Babylonian data to predict eclipses. The distance between the nearby planetary objects were conducted by Eratosthenes and Aristarchus, 250 BC. Ptolemy, 200 AD, an ancient Greek astronomer and mathematician, provided the mathematical foundation of the solar system model. Nicolaus Copernicus, 1500, reintroduced the heliocentric theory that challenged the doctrine of the Catholic Church. Tycho Brahe, 1580, is considered the first astronomical observer. He founded the Danish Observatory where he tried to measure the accurate position of the planet and star. Johannes Kepler, 1600, who is a student of Tycho, utilized the data from Brahe's observations and formulated from the law of planetary motion that corrected by conflict are physical